Hello, AP Physics 1 students. Okay, so problem 6, hopefully you recognize, is a torques problem, or to be more specific, a rotational equilibrium problem. And so we start off here with sigma tau equals 0. This is pretty much the seesaw problem all over again. Well, to be absolutely honest, if you just looked at this from sort of a common sense point of view and didn't really show all the physics behind it, you'll still get to the same solution and it's completely valid. But if we want to go from our physics solution, we start with sigma tau equals 0. The system is rotational equilibrium. We have to establish one direction is positive, the other is negative. I went with the convention of counterclockwise being the positive direction of rotation, although to be honest, you get the same results either way. We have to balance out the torques. Remember, torque is RF sine theta. And so here is the position vector for the left-hand mass. Here's the mass of the left times g because it's RF times sine of theta L. So I'm just putting all the subscripts L here for the left-hand mass. Same deal here. All the subscripts R for the right-hand mass. It's got to sum to 0. Set them equal to each other. The g's obviously cancel out. And all the angles are 90 degrees. Remember, the angles between the position vector, which is just pointing horizontally, and the force vector, which is the weight vector, which is pointing vertically. It's a 90-degree angle between them. Sine 90 is 1, so that drops out. So we just have Rm equals Rm. So RL ML equals RR MR. So it's 2 points for showing some recognition that the torques have to cancel out or things are balanced out. Any way you did that is fine. And then we're solving for the ratio ML over MR, which is now going to be the ratio of RR over RL. And the right-hand mass is 17 centimeters from the fulcrum, and the left-hand mass is 10 centimeters from the fulcrum. Because remember, these position vectors are always measured from the pivot point, with the point being at the 25 centimeter mark. And so distance from 25, distance from 25. And so we get our ratio 1.7. Great. And just 1 point for showing that. Very straightforward. Okay, then we get to part B, where it gets a little more interesting. We shift the pivot point, and it seems like everything should be fine, right? If you say that the torques, if you calculate the net torque, we should actually get to 0. Here's the right-hand mass, which is 8.5 centimeters from the pivot point. Here's the left-hand mass, which I wrote as 1.7 mr. Remember, in the previous part we just proved that the left-hand mass is 1.7 times the right-hand mass, so I just went ahead and substitute it in this way. So everything's in terms of the right-hand mass, whatever that is. And so 5 times 1.7 ends up being 8.5. And so these should sum up to be 0 net torque. It seems like it should be in balance. However, the system is still rotating, which means there must be more, as I call it, positive torque than negative torque. In other words, there's got to be something rotating in the counterclockwise direction opposed to the clockwise direction. There's got to be something there that we're not accounting for. So hopefully you got to at least this point. Right? So the final part of this, that'll get you the final points, is recognizing what's happening, and it's the weight of the half-meter stick itself. When it was at the midpoint, the weight of it passed right through the fulcrum, and so offered no torque to the system. But now, it's moved off center. It's on the 35 centimeter mark, so there's more wood on the left than on the right, so that part is providing a weight force that is not opposed by the normal force, or is not through the pivot point, and so it's going to cause more torque in that counterclockwise direction. The whole system will be out of balance. It will rotate and accelerate in the counterclockwise orientation. These are the important parts here. Recognizing that something must be tending to still rotate the system, and then the final part here is recognizing that's the extra wood on the left compared to the right.